Hi guys, I hope you all are fine. Today I want to teach you a very main resource type of the Kubernetes, which is called services. Services we will talk about today. So there is three types of services. One is the cluster IP, one is the node port, and third is the external LB. So for my perspective, the service is the name of the Kubernetes, and it's like a load balancer. So we will talk about the one by one. The cluster IP. What is the cluster IP? Is here as a services. What is the node port of the services? What is the external load balancer as a services? So let's talk about the ex cluster IP. So let me write here and make a scenario of your cluster IP. So if you have a ports which have the container and then services is running on that container is port 80, and this is your port as well. So we have the port 1 and IP of the port is the 1 IP. We have another port and then C2 and P2 is name of that port and IP is the 2. So there is, let's suppose there is two services are running on different ports and different containers. So this services is the web services and this services are the MySQL services. So MySQL services are you want to use, or both are want to use to their services and connect to internally. So there is something between them. There is something between them to communicate these ports between them. So and then services can be reached out to as well. So we need here a program, or that is program is called SVC, that is Kubernetes services. So how can we use it and how can we make it and how can we means possible to communicate between them? So there is means a program. The program has some IP and the port. So and then program has to register these node container or OS or port to their in this program, and this program also need to be added in this program with the help of as a EP, that is called endpoint. But the problem is that how can the program is registered into the in the program. So one is the because we know only that container have the IP, but IP cannot be means have to means I'll always change. So let's suppose we have done one time that IP is 1 and we have write the code that you have one IP and you can be expose or means access their services with the help of IP of 1. But what happen if container has been down or your services have been need to be rephrased or need to be changed and you have relaunched the port and the port IP will be changed. Now its port IP is 3. Now services says that I don't have the one, so I can't access. I can't give these the services of the from the port 1 because we don't have the port 1 right now. We have the port 3. So we have here is the solution, which is solution is called selector. So in selector we will put the values of our ports with the help of labels, and we have already very used and familiar with the labels. Let's suppose we have the labels with app and web. So in the same time we in our services we have write the selector code that you have to always look into the app equal to web. If you find them, then you have to register that ports in your services in your services. If this has the ports has the label of app into web, so you can use, or add app into web. Use these ports and add into the program. So that so what is the cluster IP? So the cluster IP services is by default. Whenever you default, whenever you are using creating any services without providing the type of the services, the type services will always created a default with the help with the type of cluster IP. Service will always created by default cluster IP, and cluster IP will accessible only within the cluster. It's only access within the cluster, within the nodes, within the port. Okay, so let's you have so we have the service here. We have the service. So let me clean it, and we have the service have the IP, service has the port, and that port has been always use the selector and give the uh, app into the label, and always check or searching for these type of ports. And we have the ports, and ports have the app into the labels here, and these ports are always be registered with the help of selectors. So the things will be come up here. So we have three types of and then we have means ports. So ports have been port have been launched and have the services listing onto the 80. Let's suppose we have this port because we have the image and we launched and we have created that image, and we know how on which ports of my services will be listened. Let's suppose we have created the image, and my list ports, my application will listen port 80, and there is a service, and then have the IP of that service, and then there is a ports. There are three types of ports in Kubernetes. One is the port, simple port. One is the node port. One is the target port. So it's this port is related to your SVC port. Simple. This port is your VM port. We will talk about later this one. And this port is your container port. What is the your whatever your services are running on that one. So let's see. This is called our target port. And this port is simple a port. And we will talk about the NodePort as well with the help of in next upcoming little bit later. So let's create a simple services of as a type of cluster IP. So let's move on it and create it. So let's move on to the our code. I have already written the code, so let me explain you code line by line. So this is the API version we have already talked about. This is the kind is the services. We are creating the services or resource of the in the Kubernetes, that is called services. There is the metadata with the name of this services is it would be my LB1. Then we have the specification. In specification we have using selector or searcher like that always search app equal to the web, and once it finds, then he means we provide the ports. Let me just remove it here. uh, Ports, and the target ports is means 80. We have the container port, and the port is our service port. So there is not nothing like that. So we have just created this services. Let's create it. Let's first of all check is if any services are running on it, as we see. So there is no services like one, so that let's create it. Kubectl create -app sc1. The service have been created. So get sport, sorry, get svc. So now the I cluster, my name of the a services is my LB1, the type is cluster IP, and the IP of my cluster IP, and then the ports of my cluster. So let's see and more describe and see deep dive in the cluster SVC, my LB1. So it always using app looking to the app equal to web, the type is cluster IP, and then endpoint there is no endpoints, and the target port is always listening to the 80 port, and the port of my SVC is service or program port is 8081, which are using internally. Cluster IP LB always listen to the internal of your cluster. So let's move, and we have in previous lecture RC in my previous videos. So let's move on to the RC file. I have created it. In RC5 I have selector have app equal to 1, and my template ports labels also app equal to 1. So we have seen in previously in describe SVC there is no endpoints, so it's always looking to the app equal to the web labels. So let's create RC, because in we have in RC we have provided the labels in the templates form, template section, that we have the app into the web. So once it's created, so let's check it first, the ports have been created or not. Sorry. So ports have been created. Let's check the describe command and see we have 3 endpoints come up automatically or dynamically. So because they have the labels of app into the web. If we don't have the services of app into the web, and we want to means get into the these services, it will not be part of that service, because it's always searching for the app. And if you have the ports, or and if you have another services which have the selector is app1 equal to web2, so it will not be the part of these services, and it will not be listen, or it will not be communicate to that. So we have another ways we can communicate. So let's, this is the concept of cluster IP, and it's just only used within the cluster. So you can use or curl this on the port 0801, you will be get the ports results whatever you have in your ports or application. So let's move on to the NodePort. So this is cluster IP, and now we have to move on to the NodePort. So NodePort we have means create. So first of all, let me just show you a NodePort. What is this? NodePort is like expose your services to the outside the world. So how it will be done? So let's done it. So we have means VM. VM has the node name like, and node should have some port. We will create it. And we have already a services running, because this is a cluster IP we have already created. This is means IP and the port, and this is called SVC. And we have inside the SVC we have means container 1 or container 2, they are communicated and they are listening to the 80, and this is our listening to the 8081. Let's see. And we in VM we have the in ethernet card which are talking to the outside the world. So this is ground. So what happen, or how can we my client to access my this port? How can my client will be communicate to the this port and get the data? So for that we have means a client need to be request to the particular IP or particular port. Okay, then once is port is received this one, so we have some program running here, and that program will talk about to the internally your cluster IP or cluster resources, cluster SVC, SVC, and then SVC will receive the packet and go to the your container and forward that packet to them, and then it will be write that and it will be reach up to this one. So how can we achieve this thing? So we have to expose our node, expose our node with the port. Means a service we have to create it like NodePort. NodePort as a services we have to create. The type of the services should be a NodePort, because uh, we have to provide the services outside the world. So once we have given the type of the services, the NodePort, then it will be come up and easily get the services. So we have to expose it here, and the IP where we have used the IP of our node, and port will be created randomly generated. We can do it or we can fix it as well. Okay, but for this the program which are using and communicated to internally, there that is program is called kubeproxy. Here two times our kubeproxy are done, reverse proxy is been done two times. So once the packet should be come in, sorry, packet should be come in, and then it should be right divert into the container, and then it will be come up again. So how can we create the NodePort as a service? The type should be the service of the NodePort. So by default nature we know that it's a cluster IP, but if we want that my services should be a NodePort, so how can we do it? Let's check and do some changes in the code. So let's we have to create again a copy. Let me copy it. C2 YM. Okay, C2 YML. And now there is no type of code, no type of code is type of service is written here. If type is written here in the specification, so you have to assume that the services is something like that one. So node port. Okay, and after that we have to means put the a node port as well. Let's suppose 33301. Okay, I have put it 3001. So my type of the services is now node port, and my node port will listen on this port, and it will be redirected to the 8081, and then it will be connect to my container, and in a container who those container who have the labels of app into the web. So let's create this one. If any error will be come up, so we will sort out this one. So minus s2 this one. So it's already says my axis, yeah, we because we have copied. So just move and change the name. So service have been created. Get SVC. So first of all, once the SVC have been done it, so we check the services are running or not. My node port is 301. So my services are accessible from the outside the world or not. So first of all, we need to know about the node. Node is there's the IP of this. So let me check it first. So let's have 10.82.3.193 and this one. So now it's come up, it's working. The things are coming from my node ports. So how can this thing achieve? So first, request comes from the client. Request comes from the client with the IP of, let me IP of IP of 193 and colon 3001. The packet will be sent it to the this port, and then reverse proxy will be help to this one. We have the 80801 SVC node port, and then it will be redirected because we have registered the no ports here, so it will be get the IP of 80 or port with the IP and get the services and back into the client, as we have seen in my means practical. So I hope you understand the NodePort concept. Now last part of our services is the external load balancer. All are the external, because all are the load balancer as well, because we have let's just talk about is this, then I will explain you about that load balancer. So we have the external load balance, means we have the AWS load balancer, we have the GCP, we have others one as well. So multiple things we have in my in my uh, in the public cloud. Multiple public clouds we have, in multiple public clouds we have the load balancer. We have the ELB here, so we can use that added ELB in our Kubernetes cluster. Let's suppose we have the ELB, and ELB has to connect it to the our cluster, and cluster has the ports. So then ELB is added to the ports here. So customer will come, client will come to the first of all AWS ELB services, and then hit into my services, and then it will go and push and get the request from the ports. So this is the external load balancer. We need a lab on it to configure the external load balancer. We need the AWS or a public cloud ELB. So I will come up with a practical as well. So I was talking about the load balancer. All the services is like a load balancer. Actually, this is a service. Whatever is the service we have, we have the cluster IP, we have the node IP, we have the external. So we have the multiple ports are added here. Okay, so whenever the service will whenever the request come to the SVC, so it will be redirect to the load balancing itself, or provide the load balancing services to the customer by default. So one first packet goes here, 2 3 4 5, so it the load balancing done by itself. We don't worry about to configure the load balancing configuration in the SVC. So I hope you guys like this video, and make the create concept of your services about in the Kubernetes. So if you have any confusion, any problem, so you can ask and share with me. If you have any suggestion, to please let me know. If you have seen that I have done something mistake, so please let me know. Thank you guys watching for video. Thanks, bye.